ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Welcome back to the session 8 of Unit 2, that is by name Transmission of Powers, of the course name Mechanics of Machine, 3rd semester, Mechanical Engineering Program, on behalf of Department of Collegiate and Technical Educations. I welcome you back all. In this session, what you are going to learn means at the end of the session, the students are able to understand the gear drives and classification of gear drives. Outline here, in this session outline is first we will see the introduction to gear drives, then classification of gears we will see here. Then introduction to gears. What actually the gear is there? So the gears are the toothed wheels used for the transmission of motion from one shaft to another shaft. That is known as a gears. So they are having a like this here. Toothed wheels are there. These are the toothed wheels. They are mainly used to transmit the motion or power from one shaft to another shaft, or from driver to driven, or between a shaft and a slide. So not compulsorily the both the gears should be a toothed one only. One may be a shaft is there, another it may be a slider. This is also comes under the gears only. So here you see here, these are the gears are there. This is one gear, this is another gear. They are having a tooth over their periphery. These tooths are meshing each other to transmit the motions. These are used to transmit the motion. This is achieved. This can be achieved successively engaging the teeth here. So I can achieve the power transmission only when I am successfully engaging the teeth. So one wheel teeth, a toothed wheel, one toothed wheel should mesh with the other tooth wheel. Then only I can transmit the power here. So no intermediate link or connector is there. There is no intermediate link is there here. They are directly coupled. So they are directly transmitting the power from driver shaft to driven shaft. So this is a shaft is there. This one is shaft A shaft and B shaft here. So they are directly transmitting the power here. Intermediate link, that is a kinematic link. Intermediate link means one which is used at the as a media between a driver and driven. You might have observed in a belt drive. If I want to transmit the power from a driver to driven means in a driver shaft a pulley is fixed. In the driven shaft, over that one pulley is fixed. And the media between those two is a belt pulley is there. That is, belt pulley is having a linear motions. Okay, whereas driver and driven are having a rotary motion. Here one rotary motion is converted into other rotary motions. One is rotating in a anti-clockwise, which means other will rotate in a clockwise directions. That is, I don't have any intermediate between the driver shaft and driven shafts. They are directly connected here. Now, coming to the introduction to gear, further we can introduce here. Effect of slipping is to reduce the velocity ratio of this system. Slipping means what? Effect of slipping is to reduce the velocity ratio of the slipping. Slipping means, you might have seen in a belt drive system. Slip means what? Moving a driver pulley without carrying a belt on the driver side. Moving a driver pulley without carrying a belt is known as slip is there. Slip is occurring. The driver alone will rotate without carrying the belt. That is the slip is there in the belt drive. This is there on the driven side, driver side. Whereas in the driven side, moving the belt will move without carrying the driven pulley or a follower. That is, this is there on the follower side. So slip is moving without carrying the other part. Is the slip is there. So effect of slip is to reduce the velocity ratio of the system. So system is there, no? It reduces the velocity ratio. We have discussed in the previous sessions that the slipping of belt or rope is a common phenomena in the transmission of motion or power between the shafts. This is very common phenomena. But the same slipping can very muchly reduce their. We can say their gear drives are positive drives. There is no slips from whatever the input shaft is rotating. No, at the same speed the output shaft is rotating. So that is a positive drive. That is a positive drive is there. Here velocity ratio is maintained because if slip is there means some speed decreases will occur here. So because of this one, that is because of the positive drive, because of the constant velocity ratio. So these gear drives are used in precious machines where a definite velocity ratio is very essential, as in watch mechanism. In such case, the transmission of motion or power is carried out by means of a gear or a toothed wheel. So because of two things only, one is a positive drive, another positive drive is achieved because of the zero slip. Zero slip is there. So this is the things are there. Generally used where the center distance between the driver and the follower is very small. So these type of drives are generally used wherever the center distance between the driver and followers are very small and requires positive drive. So these drives are very commonly used here. Okay. So coming to the friction wheels. Okay, in friction wheel is there no? The motion and power transmitted between the gears is kinematically and equivalent to that transmitted by friction wheel or discs here. To understand this concept, let's take disc. This is a disc is there, or I consider two plane disc. These are the two plane disc is there. This is a disc is a plane disc and B disc is a plane disc. So how the motion is transmitted? If I want to understand here, no. So when A is rotating, no, what it will do? It will have an axial force is there. This is have an axial force. Axial force is there here. So here this disc is there, no. Disc is mounted on a shaft A, whereas this disc is mounted on a shaft B. So here, as I told, no, when A is rotating, when A is a driver here, A is a driver and B is a driven. I want to A is connected to motor and B is connected to some machines. If A is rotating means what it will do? It will have a tangential force. Sorry, tangential force is there here. Tangential force is acting on the B. This tangential force, what they will do? They will allow to have a tangential force is there. Tangential force exerted by the wheel A does not exceed the maximum frictional force. This frictional force, tangential force exerted by A on B should not exceed the this frictional force F is equal to mu Rn. It should not exceed this force. If it is exceeding the frictional force means a slip is occurring here. A slip will be occurring here. So this is rotating. So this will carry the wheel B until your frictional force is less than the tangential force is less than the frictional force. Once if your tangential force is greater than the frictional force means then a slip will occur here. So that is how we can transmit one motion to the other motion in this one. So this can be very much achieved with the help of having a toothed over the wheels. If I am having a tooth, no, I can easily engage here. They can easily and progressively engage the teeth, and they can transmit the motion here. Then there is a there is not at all a chances of coming friction. There is no friction is there. Okay, here friction, there is a chances of occurring friction, but once we made a tooth over both the driver and follower means there is no chances of friction there. So advantages of gears here, a positive velocity ratio is there here. This positive velocity ratio used for transmitting large power. They are used for transmitting large power. High efficiency is there here. Reliable service is there. Compact in layout. Okay. Transmission of power transmission of power between shafts of small center distance. These are the advantages are there. High velocity, positive velocity ratio means a constant velocity ratio is there here, and used for transmitting large power. I can transmit a large amount of power from one shaft to another shaft here. High efficiency. The efficiency is higher. That is, output by input is higher here. Reliable service. Compact in layout. Okay, compact means small. Compact is there. Okay. Transmission of power between shafts of smaller center distance. These are advantages. Now coming to disadvantages. The manufacturing of gear requires special tools and equipments. What special tools means? Hobbing tools are required here. Hobbing tools are there. So if I want to manufacture a gear means I require a hobbing tool here. The error in cutting teeth may cause vibration and noise during the operations. So if I am cutting a tooth over the disc, no, if some errors occurs, then that will cause a vibration when it is in operation. A slight error will have a vibration. That is the disadvantages. This can be much overcome with the help of CNC machine. Nowadays, the gears are manufactured on a CNC machines. The gear drives are costly and maintenance cost is also very high. So of course gear drives is costly and maintenance cost is very high. So what type of maintenance? Gear drives requires careful attention for lubrication and cleanliness. We have to lubricate the gear drives. So frequently you have to lubricate and you have to change the oils in a gear drives. Then only they will have a good performance. And cleanliness, we have to maintain that one. So then next, gear drives also requires precise alignment of shaft. So alignment is that is the axis of rotation of the shaft should uh, be maintained very accurately. That is alignment. So if I want to join a two axis means what we have to do, the two axis shaft should be in a one line only. In a one line. If I'm let's say one example. So here the alignment of the shaft is very much required. If it is misaligned means then there is a chances of noises will occur here. So classification of gears. Gears are mainly classified into four categories. Four categories are there. According to the position of the axis of the shaft. That is the first category of the gear drive. This is a very important one. According to the position of the axis of the shaft. According to the peripheral velocity of the gears. Peripheral velocity is there, okay. According to the type of gearing. Then lastly, according to the position of teeth on the gear surface. So these are the four classification is there. Now we will see one by one. According to the position of the axis of the shaft. There are mainly three types, subcategories, three types is there. One is the parallel gear is there, another is a intersecting gears, and one more is a non-intersecting and non-parallel gears. In parallel gears, we are having an example only I have taken is spur gear and helical gear. Okay, these are the parallel gears are there. Intersecting gears, bevel gears and helical bevel gears are there. Non-intersecting and non-parallel gears means spiral gears. Spiral gears are there. Okay. Now let's understand what is parallel, what is mean by intersecting, and what is mean by non-intersecting and non-parallel. Now you see here in this figure, parallel axis means these two are the shafts are there. Okay. So one which is carrying a driver. Is there another which is carrying the driven. So these two shafts are known, they are carrying the gears here. The axis of rotation of driver and axis of rotation of the driven are parallel to each other. They are parallel to each other. So these are called parallel gears. If the axis of rotation of the driver and driven is parallel, It's a parallel gears are there. They are example for spur gear and helical gears. Here we are studying these two. Uh, Little detail. uh, Intersecting gears. Intersecting gears means, so here the axis of rotations are there, no, they are going to meet at some particular point, that is the intersecting point. If I extend the axis of rotation here, axis of rotation of this one and axis of rotation of this is there, okay. So if it's there in a x-axis, if it is there in a y-axis, they are going to meet at some point, x-axis and y-axis. So they are perpendicular to each other here, 90 degrees there. The two axes of the rotation of the shafts are perpendicular to each other. Here they are not parallel here, they are perpendicular to each other but intersecting. They will intersect. So these are, here we are studying bevel gears and helical bevel gears. Okay. These two are the intersecting gears are there. These bevel gears are very commonly used in automobiles, like in differentials. So these bevel gears are very commonly used in bevel gears. Then non-intersecting, non-parallel shafts. So now you see, observe here, this is a non-intersecting and non-parallel shaft. So this is it's there in a some axis, x-axis, other is there in a y-axis, but some distance is there. They are not intersect each other. One axis is there over the other. One axis is there over the other. So here the example is a spiral gear is there. Spiral gears. Okay, this is there about parallel gears, intersecting gears, non-intersecting and non-parallel gears. Now, classification of gears is there. The second category, according to the peripheral velocity of the gears. What is gears are classified based on the peripheral velocity of the gear. If the velocity is less than 3 meter per second, then those are called as a low velocity gears. Those are called as a low velocity gears. If the velocity is between 3 to 15 meter per second, if the velocity is there between 3 to 15 meters per second, those are called as a medium velocity gears. If the velocity is more than 15 meter per second, those are called as a high velocity gears. This is the second category of the shaft is there. The next is according to the type of gearing. Whether type of gearing is there, external gearing, internal gearing and rack and pinion. So majorly the type of gearing is external gearing and internal gearing. Rack and pinion is little important is given here also. So this is your third category of the shaft. Now the fourth category classification of the shaft is according to the position of the teeth on gear surface. What type of teeth are there on the gear surface? Straight teeth gears. If the gear teeth are straight with the axis of rotation, then those are called as a spur gears. If the gear teeth are inclined to the axis of rotation, then those are called as a helical gears. If the axis of rotations are curved teeth gear with respect to the axis of rotation, then those are called as a spiral gears here. Spiral gears. Now we will see one by one. So a classification I given I will recall the classification of the gears, or some books it's given a types of gears also. So gears can be classified based on the position of the axis of shaft. This is the first category. That is, here gears are classified based on the peripheral velocity of the gears, and gears are classified based on the type of gearing. And the fourth one, gears are classified based on the position of the teeth on the gear surface. There. On position of the axis of the shaft, the gears are classified as parallel axis shaft, intersecting, non-intersecting, and non-parallel axis shaft is there. So, according to the peripheral velocity of the gears, the shafts are classified into low velocity, medium velocity, and high velocity. On type of gearing, the shafts are classified as external gearing, internal gearing, and rack and pinion. According to the position of the teeth on the gear surface, the shafts are classified into straight gearing, example is a spur gear, inclined gearing, example is a helical gear, curved gearings, example is a spiral gears. These are the classification. This classification is based on the position of the axis of the shaft, that is a parallel axis, intersecting and non-intersecting and non-parallel axis. These are further having three more types. Examples I have given here. Based on the axis of the shaft, parallel axis of gears are classified into spur gear, helical gears, herringbone gears is there. Intersecting, bevel gears, non-intersecting, non-parallel, spiral gears, and worm wheel. So we will discuss all these gears in detail. Spur gears, you see here. The very first is a spur gear. So here the teeth are straight and parallel to the shaft axis. So now you see here this is a spur gear. These teeth are there, no? These are straight and parallel to the axis of rotation of the shaft. So you observe the teeth here. They are straight one. So teeth are straight and parallel to the axis of the rotation of the shaft and transmit power and motion between rotating two parallel shafts only. Between the two parallel shaft only these type of shaft gears are used. So future here easy to manufacture. Spur gears is very easy to manufacture. There will be no axial force. Axial forces are not there, only tangential force is there. Okay, relatively easy to produce high quality gears. I can produce very high quality gears here. If I am using a CNC machine, if I want to produce a gears on a CNC machine, I can easily produce a very high quality gears. And this is the commonest type. Once I say gear means, I don't, anyone says spur gear only. Don't say helical or spur. They will show this type of gear as a spur gears. And application transmission components. So these are used in a transmission of components. If I want to transmit power from one shaft to another shaft, then they are using this type of gears only. Now coming to the second type, which is very commonly used in machineries, helical gears. Teeth are twisted oblique to the gear axis. So you see here, teeth are twisted here. They are twisted. A light twist is there, light bend is there. Okay. So the hand of helix is designed. The hand of helix is designated as either left or right. Designated as either left or right. Now you see here in the above figure, it's having a left left hand helical gears. Okay, and below one is a right hand helical gear is there. So this if is there, this is a driver and this is a driven. So this is a left hand helical gear and right hand helical gears. Okay, so this one is the right hand and left hand helical gears mate has a set. So right hand and left hand both will make a set only. So I can't transmit the power from left hand helical gear to left hand helical gear. So I should have a other one. If I am using a right hand left hand helical gear, then the other gear mating gear should be the right hand only. Then only I can transmit the power. But the helix angle should be same here. The helix angle is there, no? That should be same. Okay. That is the helical gear is there. So future here, so as I told, no, these gears are very much used in the machineries. Has high strength compared with the spur gears. They can transmit higher power compared to the spur gear. Effective in reducing noise vibration compared with the spur gear. So here the effective in reducing the noise means they are smoothly engages and disengages. Because of the helix angle, they will do? They will smoothly engage and disengage. So gear in mesh produce thrust force in the axial direction. Application transmission components, automobiles, speed reducers, etc. are they are there. Transmission component very commonly these are used in automobiles and speed reducers. Helical gears here. You observe here. This is an helical gear is there. This is very commonly used helical gears are there. Okay. So here they are having a left hand helical gears and other is having a right hand helical. So they we have to use opposite only. If I am using a driver on a driver a right hand helical gear means on the driven I can use only left hand helical gears. So this is the things are. So this is an example for herringbone gears is there here. Herringbone gears are very commonly known as a double helical gears only. So single is a helical gear, where a double helical gear is known as a herringbone gears. Herringbone gears. The double helical gears are known as a herringbone gears. Now you observe here, if I want to transmit the motion from driver to driven here. So here is this is there, no? We are having a double helical gears here. One right hand is there, another left hand is there. Left hand is made are placed together over the one shaft only. These two gears are placed over the only one shaft, either driver and driven, or on the other also they will make the same things. Okay. Okay, bevel gear. Coming to the third important one is a bevel gear. What is the bevel gear means? One of a pair of gears used to connect two shafts whose axes intersect and pitch surfaces are cones. You see here the pitch surface is there, no? They are making a cone. Cones are there. Okay. So this is the thing. No, this one is you observe here. So the pair of gears used to connect two shafts whose axis intersect here. So you see here this axis is there, no? This is there in a x-axis, and this one is there in a y-axis. The x-axis horizontal axis, y-axis vertical axis, and both are going to mate at some particular point. So that's known as the intersect. Their axes are mating. Axes are meeting at particular point. The features relatively easy to manufacture. So this is simple helical gear is there. A straight helical gear I can. Relatively easy to manufacture, provides reduction ratio up to 1:5. Application is machine tools, printing press, especially suitable for differential gear unit. Differential gear units are there on the is there in automobile, four-wheelers, heavy vehicles. Differential are there. Even military vehicles are there. No, four-wheelers. They are having a double differential. They are having a front side as well as back side differential is there, so, to move easily on the upper side. So this is the differential gears. You observe this is also one type of helical gear is there. Their axis of rotations are going to meet at some particular point here. So that is the axis intersect with the axis intersects. This is the example of the bevel gears. Now coming to the spiral gears. Spiral gears are there, no? These are the two non-intersecting, non-parallel, that is non-coplanar shaft connected by gears. So these shaft axes will never intersect each other. They will never intersect each other, and they are not in a one plane and non-parallel. Both are non-parallel. The axis of rotation of one shaft and axis of rotation of the other shaft, they are not parallel. These gears are called as skew bevel gears. This type of gearing also have a line contact. A line contact is there. The rotation of each about the axis generate the two pitch surfaces known as hyperboloids. Okay, so this one is there here. Okay, worm and worm wheel. You see here, this one is a worm is there, whereas this is the worm wheel is there. Worm is a shank having at least one complete tooth or thread. So here, worm is a shank having at least one complete tooth or thread around the pitch surface. This is a driver of the worm wheel. This is acting as a driver. So worm is acting as a driver always. Always the worm will be driver is there. Whereas worm wheel is a gear with the teeth cut on an angle to the driven by worm. They are driven. Worm are known as the driven ones. So this is a driver and the worm wheel is a driven. Now you see the features. It's having some special features are there. To lock the doors, all those things. So features requires larger reduction ratios for a given center distance. A larger reduction ratio is there. It can reduce up to 1 is to 200, up to 1 is to 200. Quite smooth action. They are having a quite smooth action is there. Worm wheel is not feasible to drive a worm except for special condition. Okay, application here you see speed reducer is there. Anti-reversing gear device making the most of its self-locking feature. So this anti-reversing gear device making the most of its self-locking. This special feature is used in the door locking. So this gear is there no. Oh, here you see observe worm can drive worm wheel. Worm wheel will not drive the worm. So if I rotate the worm will not rotate. Anti-locking is there. It's not allowed to rotate. So that is the special thing is there. So I can transmit the motion from worm to worm wheel, but I can't reverse rotate. If I rotate the worm will not rotate. They'll lock there itself. Okay. Okay, that is the special one. These are again another application is it's very commonly used in machine tool indexing devices. So this is very commonly used in indexing milling machines. They are very commonly used. So this is your worm and this is your worm mill. Now the next one is a meter gear. Meter gear is there, no? It is a special class of bevel gear only. It's a special class of bevel gear. When why it's called meter means when equal bevel gears that's having equal teeth connected to two shafts whose axes are mutually perpendicular, then the bevel gears are known as a meters or meter gears. So these are having a equal teeth are there. If these are equal teeth on the driver and the driven, these two gears are there. No, if they are having a equal teeth and the same one, the equal teeth are there. If it is having some number of teeth and these are having some number of teeth, if those are equal, then that is called the meter gears, and the ratio is 1 is to 1 only. When there are equal teeth means automatically the ratio will be the 1 is to 1 only. Now this till now we have seen the classification of shaft based on according to the axis of rotation of the shaft, according to the axis of rotation of the shaft. Now we will see the second important category, that is classification of the shaft based on or according to the peripheral velocity of the gears. So as I told, according to the peripheral velocity of the gears, they are classified into three categories. One is low velocity gears, which are having less than 3 meter per second. That's a peripheral velocity. If the peripheral velocity is less than 3 meter per second. Medium velocity gears between 3 to 15 meter per second. High velocity gears more than 15 meter per second is there. Okay. According to the type of gearing, so classification based on according to the type of gearing here. They are external gearing, internal gearing, and rack and pinion. We will see here one by one. External gearing. So you see here, observe this is an external gearing. A spur gear is there, no? It's an external gearing only. If the gears are made externally, then that is known as the external gearing. Spur gear, helical gears, bevel gears. These are all comes under the external gearings only. But in external gearing, what we call here, the gears of the two shafts mesh externally with each other. The larger of these two wheels is called spur wheel. The largest of the wheel is known as a spur wheel or a spur gear, and the smaller wheel is called a pinion gear. This is known as a pinion. Spur gear and pinion. These are the things are there. The motion of the two wheel is always unlike here. If one is rotating in clockwise direction, other will rotate in an anti-clockwise direction. So that is the motions are always unlike here, opposite to each other. Now internal gearing you see here, internal gearing is there. The gear of the two shafts mesh internally with each other. Here internally meshing. So they are meshing internally with each other. The larger of these two wheel is called annular wheel. The outer wheel is known as the annular wheel and the smaller wheel is called a pinion. This is the pinion. So this one is there, no? Annular wheel is there and this is the pinion. Pinion is there. Okay. Now rack and pinion. Here the motion of the two wheel is always like, you see here rack and pinion is there, no? But this is the bottom is a rack is there, and pinion is also circle is there. Bottom wheel is a rack. The gear of a shaft measures externally and internally with the gear in a straight line. Such type of gear is called rack and pinion. The straight line gear is called rack. The straight line gear, the straight one is there, no? This is called a rack. And the circular wheel is called pinion. A circular one is known as a pinion. So what's the major thing here is that when I say rack and pinion means, first thing comes in my mind is it converts linear motion into a rotary motions or vice versa. What it will do, the main purpose of the rack and pinion is to convert linear motion into a rotary motion or rotary motion into a linear motion. That is the main purpose of rack and pinion. One size, anyone says rack and pinion means which is mainly used to convert rotary motion into a linear motion and linear motion into a rotary motions. So whereas in spur gears, helical gears, or other type of gears, what we are going to do there, we are converting a rotary motion into a rotary motions only, but in an unlike direction. But if one is rotating in a clockwise, other will rotate in a anti-clockwise direction. But here we are converting a rotary motion into a linear motion or linear motion into a rotary motions. So you observe this one. Okay. So what they are doing here? Rack is there. This is the rack. They are moving linearly, whereas your pinion is moving in a rotational motions. Okay. Then the last one, according to the position of the teeth on the gear surfaces, they are straight teeth gears are known as a spur gears. Now you can understand. Straight teeth gears are known as a spur gear. Straight teeth gear means the teeth are parallel to the axis of rotation. Inclined teeth gear, if the teeth are inclined to the axis of rotation, then that is known as the helical gears. If a curved teeth gear means if the teeth are curved in shape, then those are known as spiral gears. So these are there. Now you see here, this one is the very first is the spur gear is there. This is the helical gears. This is one is a rack. This one is a bevel gears here. This one is the spiral bevel gears is there. This is a screw gears. Then meter gears. In meter gears, the teeth are equals. So on the driver and the driven, you observe here the teeth are one is having a larger number of teeth, whereas other is having small number of teeth. If the teeth are equal, here also we are having a larger number of teeth, whereas in this one they are having a smaller number of teeth. Whereas in meter gear, the teeth are equal on a driver and driven, and the velocity ratio is 1:1 only. Then warm and warm wheel is there. This one is the warm, whereas this is the warm wheel. So internal gear is there. That is the annular gear is there. This one is there. Okay. Okay. Still now we have studied the what is mean by gear, gear drives. What are the purpose of gears? Classification of gears. Okay. You have seen it. The classification is there. No, they are classified according to the position of the axis of the shaft. That's parallel, intersecting, non-intersecting, and secondly they are classified according to the peripheral velocity of the shaft or gears, low velocity, medium velocity, high velocity. Then according to the type of gearing, internal gearing, external gearing, and rack and pinion. And lastly we have classified according to the type of teeth, I can say according to the position of the teeth on a surface, uh, uh, that is according to the position of the teeth on the gear surface. Straight gear is there, inclined gear, and curved gears. So this much you will learn in these sessions. Okay, let's have some multiple choice questions. It's having a multiple choice question is there. Here, gear. Very first question is gear shaping is related to option A template, option B form tooth process, option C op, option D generating, The right answer is here hob. Uh, gear shaping is related to hobbing here. Hobbing is there. Okay. Now, second question. A, a dash drive is also provided when the distance between the driver and the follower is very small. Here, option A, rope, option B, belt, option C, gear, option D, chain. And the right answer here is gear. So here a gear drive is also provided when the distance between the driver and the follower is very small. If small center distance is there between the two shafts, then we have to go for the gear drive only. Okay. The next question. A dash is a rotating circular machine part having a cut teeth which mesh with other toothed part to transmit torque. Option A, rope, option B, gear, option C, belt, option C, D, chain is there. Okay, the right answer here is the gear again. Okay, and now next. Which of the following methods provide gear by generating process? Option A, fobbing, option B, casting, option C, punching, option D, milling. So the method used for generating a gear is hobbing. Hobbing method is very commonly used here. Now, fifth question: dash gears have teeth parallel to the axis of the shaft. Spur gears, skew bevel gears, spiral bevel gears, rack and pinion. And the answer is spur gears. Spur gears are their teeth parallel to the axis of the shaft. Skew bevel gears, they are having a curved teeth are there, whereas a spiral gear is also curved teeth are there. Rack and pinion is nowhere concerned. Rack is there to transmit the motion from one shaft to the other shaft. So that is a different one. Now the question is sixth question. In dash gearing, the gears of the two shafts mesh externally with each other. Option A, internal gearing, B, external gearing, C, rack and pinion, D, helical gears. So your right answer is external gearing. So in external gearing only, the gears of the two shafts mesh externally with each other. When they are meshing externally, then that is known as the external gearing. When they are meshing internally, that is known as the internal gearing. Okay, internal gearing. The next question: the two non-parallel intersecting non-parallel intersecting but coplanar shafts connected by gears. These gears are called option A, spur gear, option B, helical gear, option C, bevel gears, option D, rack and pinion. Okay, the right answer is bevel gears here. These are the non-parallel but intersecting and coplanar. One shaft will have an axis of rotation in x-axis, other will have an axis of rotation in a y-axis. They are perpendicular to each other. Okay, in bevel gears, the shafts are rotating non-parallel, non-intersecting, and coplanar in one planar only there. That those shafts are there. Then in dash gearing, the gear of the two shafts mesh internally with each other. Internal gearing, external gearing, rack and pinion, and helical gears. The right answer here is internal gearing. In internal gearing, the gears of the two shafts mesh internally, that is, internally with each other. The gears having velocity less than 3 meter per second are termed as low velocity gears, high velocity gears, medium velocity gears, and fast velocity gear? The right answer is A, low velocity gears. Here, velocity less than 3 meter per second. If the velocity of peripheral velocity of the gears here, if the peripheral velocity of the gears are less than 3 meter per second, that is known as a low velocity gears. If the peripheral velocity of the gear is more than 15 meter per second, then that is called as a high velocity gears. If the peripheral velocity is between 3 to 15 meter per second, that is called as a medium velocity gears. Fast velocity gear is not there. It's not a type of any velocity gears. Okay. So that's the things. Gears having velocity between 3 and 15 meter per second are known as low velocity gears, high velocity gears, medium velocity gears, fast velocity gears. The right answer is medium velocity gears. Okay, these are some reference books. So this is our team members. Thank you.